Hello students, welcome to the course Network Theory. In the previous video, I explained you the concept of supernode and we have seen one of the example to how to solve the network using supernode concept. So in this video, we'll look at two more examples of supernode analysis. Okay. So first one I will explain you in detail. Okay. So second one same way, so you can able to do that. Okay. Note down the problem. For the network shown in figure, find the node voltages VD and VC. Okay, so this is the network. Okay, so just look at the network. So what you have? Okay, so it is a shape of a rhombus, right? So you have, this is named as node A, B, okay, C, and this is D, and here ground is shown here, right? That means what? This is all the branches are most connected to this branch, so that's why it is made as the ground potential. Okay, so draw the network. You have 2 ohm here, so this is a dependent source here, dependent voltage source, 6I1. This is a dependent current source, 3VC. Here you have 2 ohm, 2 ohm, and 2 ohm, and here you have the 4 amps, and here you have the 8 volts. Okay, hope you have noted down. Fine. So how to solve this problem here? Okay, so which is super node here? Okay, so what are the straight away we can do the calculation here? Okay, so in the problem they have asked actually VD and VC. Okay, so they have asked only this VD and VC, but there are other two node voltages also there here, VA and VB, and they may be somewhere related to this VC and VD also. That's why our goal is to find out all the four. Okay, so then in that you will get VD and VC. Okay, so first we will have to observe. Okay, so this here, so each branch we have to observe here like this. Is there anywhere any simplification will happen? Okay, so just look at this VB here now. So and here you have the ground. That means what? Here you have the plus potential and here you have the minus potential. What you have in between this? An ideal voltage source, but it is not between non-reference node, between the reference node it is having. That's why it is not a super node, but its value is given here as in previous example we had, right? Straight away we got one of the voltage. Same way here. So VB is straight away you can write it. It is in the same polarity, right? So straight away it is 8 volt. Okay, so that's why they have not asked VB in your problem. Okay, but this VB is required in the calculation. Okay, so VD and VC they have told, but VB we got straight away. Hope you understood. So then where you have the super node here? Okay, so that you can look at. So here you see this is an voltage source. It may be dependent or independent. Okay, so that means what? VA and VD forms a super node. So super node means what? Just whatever node equations you are writing for A and D as separate node, you have to write it as one equation. Okay, and as a second equation you have to write the node voltages relating to this. Okay, again this is a current controlled voltage source, so current you have to relate. Where is the I1 current? It is shown here. See here, this is the branch they have shown. So current entering means this is side it is plus and this side it is minus. That means VB minus VC is equal to I1. Okay, VB minus VC by 2. Okay, because resistance, right? Ohm's law. Voltage is VB minus VC by 2. That you have to substitute back here. This is the controlled equation. In the beginning only concept I told you. Okay, so yesterday video just we have seen the super node. Today along with super node dependent also we are looking at. Understanding the difference? Okay, so that you are going to get. This is a super node now. So first equation here, second equation is this, and where is the third equation? That is VC. It is not a super node or anything. So simple equation. So just you have to write the equation for this. Okay, so now how to proceed? Can you write the equations now? Okay, so simple manner. So just I will try to show you have the network here. Okay, so look at. So first equation if I write, okay, I will write the super node equation only first. Okay, so this is already done. VB equal to 8 volt. Okay, VB part is over. Only need is VACD we have to calculate. Okay, VAVC VD we have to calculate. For that we will write the super node equation for this. So what is the super node for here? So it is VA minus VB by 2 KCL. VA minus VB by 2 plus VA minus 0 by 2 Okay, and this side is super node, no need to touch, plus this side also we have to write. So VD minus VC by 2 is equal to 3VC. So what is the current entering here? So nowhere here current entering, so this is the current entering here, so it is 3VC. So what is meant by VC? So it is there here, right, in the equation itself. So just you rearrange the equation, you will get an equation in the form VA VB. Okay, so you'll get a equation, sorry, VA VC and VD. In this form you will get an equation, that is the first equation. Okay, so no need to worry about that. Second equation, we are writing the super node equation, that is VA minus VD is equal to 6I1. So this is the constraint equation. Then again I1 is there, so you have to write the controlled equation. So what is I1? As I mentioned, VB minus VC by 2. So that you have to substitute here and you have to simplify. You will get the second equation same in the form of VA VB VC. Okay, so that is the second equation. So you write down already if you are okay. So later you can just verify when I am showing the equations. Then third equation you have to write as this simple node here. So what you have, VC minus VB by 2. Okay, VC minus VB by 2 plus VC minus VD by 2 is equal to 4, because 4 amp is entering the node here. And every equation, remember, wherever you get VB, okay, so it is VA VC VD here. So wherever you get VB here, so VB you have to substitute 8 volt and you have to simplify. Otherwise 4 values will come, no? So one of the value will reduce, so then you can use the equation 3 unknowns and you can solve it. Okay, I hope so far whatever I've explained you have not understood maybe. So now you have this network and I will show you the equations now one by one, so then parallelly work with me. Okay, so that you will understand. Okay, you require more attention. Okay, see, by inspection VB equal to 8 volt. How it is I have explained. Okay, so VB is 8 volt. Straight away got the value. Then A and D form a super node and applying KCL at super node. That's what I told you. VA minus VB by 2 plus VA minus 0 by 2. It is VA by 2. Okay, because ground potential, no. And VD minus VC by 2 is equal to 3VC. So just VB will substitute 8 volt where we have VB here, right? So VA minus 8 by 2, VA by 2 plus VD minus VC by 2. This VC will take it left side. It will become minus 3 VC equal to 0. So then we will simplify here VA by 2. It is splitted here, VA by 2 and this VA by 2 clubbed here plus VA by 2 and then VD by 2, then minus VC by 2 minus 3 VC and this 8 by 2 taken here because to take next step it is in the right side, because constant, no, we can take right side. You have to substitute in equation, right? Only the coefficient of VA VC VD should be there in the left side. This is equal to 0. Simplification, now you add this half and half, it becomes 2 VA by 2 means VA itself, right? So we have kept in this manner because so that we can take whole LCM. So 2 VA by 2 minus, so 1 by 2 and 3. So what you will get if you take LCM? Okay, so minus 1 by 2 VC minus 3 VC, you will get minus 7 VC by 2. Okay, so 3 by 2 means 7 by 2, right? 3 and a half means 1. Then plus VD by 2 you have written 4. Now this all the equations 2 is the common, so you 2 you can cross multiply with right side. Okay, so here 2 4 by 2 minus 8 by 2 minus 4 is taken right side plus 4 and multiply with this 2, you will get the final equation 2 VA minus 7 VC plus VD is equal to 8. So you got the first equation to solve the parameters, right? So next we'll write the constraint equation for the super node A and D. So that is VA minus VD is equal to 6I1. Okay, so which direction current voltage is shown, accordingly we have taken. Okay, so there it is written plus minus, right, this side. So this side plus means VA, right? So this side minus means minus, right? So minus VD. That's why we have taken VA minus VD. Okay, so hope it is clear. Equal to 6I1 and then controlled equation. I have not mentioned this. Okay, controlled equation you will understand. It is VB minus VC because I1 is on the this side it is shown. Okay, that means current entering the node will be plus and then current leaving the element should be minus, right? That's why VB side I have taken plus minus VC by 2. Substituting back, we have VA minus VD. So we will substitute in this 6I1. So 6 into VB minus VC by 2. Again, substitute VB equal to 8 volt. So VA minus VD left side as it is. So here 2 3s are. So 3 into VB is 8 minus VC. So just we'll rearrange the equation in the form of VA VC VD. First VA is there as it is here. Then here minus 3 VC is there right side. If I bring it left side, it will become plus 3 VC. And here minus VD is already there. So I have wrapped here. And 8 into 3, 24. Okay. One more step you can split here. 24 minus 3 VC. Then you can bring it. I have clubbed. Okay. Hope you are understanding now. Okay. So this is the second equation you got now. So now to write the third equation, you have to refer the node C. Okay. In that diagram, already I told you VC minus VB by 2 plus VC minus VD by 2 is equal to 4 amp current entering the node, right? So it is 4. Again, substitute VB equal to 8. So VC minus 8 by 2, VC minus VD by 2 equal to 4. Same as first equation, split it. VC by 2 minus 8 by 2 plus VC by 2 minus VD by 2 is equal to 4. Whole you have 2 as the LCM, but you have here 4, right? Minus 4, we can take it right side. That becomes plus 4. Okay, so again here steps have this one VC by 2, VC by 2, you will get 2 VC by 2, right? So I have, and then minus VD by 2. So this you step I have missed it. Okay, no necessary if you have understood. Equal to here 8 by 2 minus 4, minus 4 if you take right hand side plus 4. So it will be 4 plus 4 8. Now you take this 2 cross multiply, what you will get 2 VC minus VD equal to 16. How you got this equation? So you got the three equations now. Just use the calculator now. Go to complex equation mode. Three unknowns you select. Okay. Enter the first value. One is 2, B1 is minus 7, C1 is 1, D1 is 8. Second equation, A2 is 1, then B2 is 3, C2 is minus 1, D2 is 24. Third equation, okay, you don't have the VA term here. That means A3 you have to take 0, then B3 2 plus 2, and then C3 minus 1, and D3 16. Okay, so this is careful here. So VA term is not there, you have to take at 0, otherwise answer will come wrong. So if you click that, so you'll get the answer. So what I got here is, okay, so whatever x you are getting, that will be the first part of the equation. First part you are writing VA, no, that's why it is x 9.12 volt. Then you had VC, that is the y, okay, minus 1.14 volt I am getting, and then VD equal to minus 18.3 volt. Okay, so hope you have understood this calculation. Okay, so if you have not understood, go back and play the video again. Okay, so those who have understand, just verify your answers and go for the next problem. So it is same as this circuit, only thing is the names, instead of VA, VB, VC, VD, I have changed it to V1, V2, V3, V4 volt, and some of the elements placement we have changed it. Okay, so that you can do by yourselves. So now I won't explain much. Okay, so just see, so how you will do. Okay, I will show the circuit. You can pause the video, note down the circuit and do it yourselves. Okay, let it be wrong, let it be one page you are going to waste. Okay, so same as first one, you write the equations, solve it, and then play the video and see whatever you have done, where you have made mistake, why it got mistake. Okay, that is only the way you will learn the network theory. Okay, so no other. So even if I do 10 problems also, if I give the 11th problem, you will not understand. It is a by heart concept. So you have to overcome this, means whatever I am suggesting now. So pause the video, write the equation, let it be wrong, then play the video. When it comes wrong, just go back and see where I have made mistake. Clear? So then, because I could not do all the problems, right, it is not, because already one module they have specified 8 to 10 hours. I am taking them almost more, right? Basic concepts I have covered, and after that 15 plus classes I have taken already for this mesh analysis and node analysis. Okay, because it is a very important concept. Without this I could not do the remaining modules at all. Okay, so go for it. Okay, so hope you have noted down. Find the voltages V1, V2, V3, V4 in the circuit shown in figure using nodal analysis. So just see the network here. So this is 1 here, this is 2, 3 and 4, and again this is the ground, same as previous one. And even you have the voltage here, that is V1 voltage. So normally V1 will be plus minus, but the voltage is shown here reverse manner. So how you have to write? V1 equal to minus 12 volt. Okay, so then where you have the super node here between 3 and 4, see here dependent voltage source is there, nowhere else is there. You should look just outer circuit, that's it, because inner one is with respect to reference node, right? You have to see only non-reference node. 1 to nothing is there, 2 to 3 register is there, 3 to 4 you have the thing. Okay, so this is the super node. Now equation 3 and 4, so write the equation here with respect to this. V3 minus V2 is equal to, by 2 is equal to how much? Okay, V3 minus V2 by 2 plus V3, this side nothing is there, equal to 0.5 Vx. Okay, and then Vx you substitute where Vx is shown here. See here, minus plus Vx it is shown, meaning what? Plus side means this V2 minus V1 by 0.5, which is nothing but the Vx. That you have to substitute and simplify the equation. Then you have to write the constant equation between 3 and 4. You have V3 minus V4 is equal to 0.2 Vi, because plus side is this side, minus side is this side. Accordingly, right? Then where is the Vy? Here, it's shown plus this side. That means V4 minus V1 by 2.5. Sorry, voltage means V4 minus Vy. V4 minus Vy, V1. That's only you have to write. Voltage, no, not current, right? So just V4 minus V1 is Vy current, that you have to substitute. Okay, and then finally you have to write the equation for 2. This is not a super node, right? So 3 equations you will get, and everywhere you have to substitute V1 equal to minus 12 volt. This one you need to do as in the previous video. I'm going quickly so that I should not tell each and everything for you, so that you have to see the first video if you have not understood. Okay, first inspection V1 is equal to minus 12 volt. Okay, so both type I have taken. 3 and 4 forms a super node. If you write the equation V3 minus V2 by 2, V4 by 1, V4 minus V1 by 2.5 is equal to 0.5 Vx. Vx is equal to V2 minus V1, only that much. Okay, no need to take resistor part. If it is a current, you need to take V by R, Ohm's law. Okay, so substituting back in the equation here, so you simplify, you will get the first equation. Okay, V3 minus V2 by 2, V4 by 1 plus V4 minus V1 by 2.5, 0.5 V2 minus V1. So now equation is everything simplified. Now substitute V1 equal to minus 12 volt. Okay. So once you substitute it, so V3 by 2 minus V2 by 2 plus V4 by 2.5, then plus 12 by 2.5, because V1 I have substituted straight away. Minus of minus is plus, 12 by 2.5. 0.5 V2 minus V1 means minus of minus plus 12. Okay, so now you have to, V1 is already known, you have to write the equation in the form V2 V3 V4. So V2 you have to bring it everywhere. So here minus 1 by 2 is there, and here 0.5 is there. 0.5 if you take left side, minus 0.5 minus 0.5 minus 0.5, so it is minus 1 V2 plus V2 over V3. So 1 by 2 V3, only one term is there, so 0.5 V3. Okay, so I'm writing maybe straight away, but you can do one more step if you want. Then V4, you have two terms here, 1 and 1 by 2.5. You can use the calculator or you do the calculation here only. So you'll get 1.4 V4, and then 12 by 2.5. So how much you are getting? And then 12 into 0.5, how much you are getting? It may be 6 here, 12 into 0.5, and 2.5 to the, how much it is? 2.54, 4.8 I think. Okay, so this plus is there, right side if you take it will become minus 4.8, you'll get 1.2. That's what I got. It is the equation 1. Next constraint equation for the super node, V3 minus V4 is given 0.2 Vy. Okay, just you have the network, just look at Vy is equal to V4 minus V1. So that side V4 side plus is shown, that's why V4 is plus, then minus V1. So just substitute here v3 minus v4 0.2 v4 minus v1. Okay, so v3 minus v4, yeah, I have splitted here 0.2 v4 minus 0.2 v1. Now you substitute here v1 minus 12 volt. So you'll get and 0.2 v4 I have taken left side here. v3 minus v4 minus 0.2 v4 equal to minus 0.2 into minus 12. I will get v3, and this is minus 1.2 v4 is equal to minus minus plus here 12 into 2, 24 point is there, so 2.4 you are getting. That means here v2 term is 0. While substituting you should be careful. Okay, so v2 term is here 0, only have v3 and v4 term and constant term. Clear? Next, third, you write the node equation for node 2. Okay, KCL for node 2 you do. So you'll get v2 minus v1 by 0.5, because it is KCL, no, that's why current form, plus v2 minus v3 by 2 is equal to 14 amps current is entering the node there, right? That's why you have to enter. Then v1 you substitute here minus 12, so v2 by 0.5 minus of minus plus 12 by 0.5, v2 by 2 minus v3 by 2 is equal to 14. So simplify, 1 by 0.5 means 2v2 plus it is 1 by 2, 12 by 1 by 2 means 24 plus v2 by 2 minus v3 by 2 is equal to 14. So simplify now, bring it in the form v2 v3. So maybe v4 term is not there in this equation. So 2 and this one, 2 plus 1 by 2, that means what? 5 by 2 you will get. Okay, so actually one here also I have skipped it. Okay, so straight away taken like this. So 5 by 2 v2 you will get, and then minus v3 by 2 equal to, okay, so here 2 is there in the denominator, no, that we multiplied first, which is 28, and here also we have taken LCM 2, it becomes 48 here, so that 48 I have taken right side. I have skipped here too many steps. Okay, but you have to do, because elementary maths you are good at this stage. Okay, so when you do that, so you will get 5v2 minus v3 is equal to this you don't write, v3 plus 48, okay, equal to 28 was there in the previous step. Next step, 5v2 minus v3 is equal to 28. First we multiply this 14 here, 28 minus then this plus 48 this side. Okay, like that you add one step if you require. Then 5v2 minus v3 equal to minus 20. That means here when you are substituting v4 you have to do 0 v4. So you got the three equation what you require now. So just substitute in the calculator equation mode, so you'll get the three answers. Okay, a1 is minus 1, b1 is 0.5, c1 is 1.4, and d1 is 1.2. Similarly second equation. Okay, so you are careful, a2 is 0 here, v2 term is not there, 0, b2 term is 1, c2 term is minus 1.2, d2 term is plus 2.4. Next third equation, you have a3 5, b3 minus 1, c3 0, because v4 term is not there, then d3 minus 20. Okay, just click enter, so you will get the three voltage values. Just verify your answers. Okay, minus 4, 0 and 12 volt. Okay, so this is about the problem. Okay, so hope you have understood this. Okay, so everything we have covered here: independent current source if it is there, independent voltage source, dependent voltage source, dependent current source. Previous case we had the dependent current control voltage source was there. Now voltage control current source we have, voltage source we have, because voltage source only forms the super node, current source won't, right? So current source will access just current entering or leaving the node. Okay, so with this we have considered the DC networks part completely. Okay, so in the next video we will look at the node analysis for AC networks. Okay, so just go through. Okay, so day to day go through with the videos. Okay, so don't keep it pending for at least 2-3 days, so that it will be bulk at the end. Okay, so even if the college starts also, I could not do everything in detail from the beginning. Okay, wherever I have completed, from there only I have to take it. Okay, because time is also less. Okay, so hope you understand, take it seriously. Okay, so whatever possible manner, read it twice. Okay, do it twice. Okay, maybe other subjects they are not taking much videos for you, I am taking much. So don't bother about that, because my subject and maths require lots of working, and you need to do on day to day basis. Okay, at a time you could not understand this. Okay, I'm telling frankly. Okay, so day to day whatever you are doing, it continue. Okay, and don't stop that. Okay, so it will definitely give you a result. Okay, so not only with this subject I'm telling. Okay, this subject is very important for your all the competitive examinations. If you are going technical side like gate exams, or if you are going through other yeah, UPSC exams. Okay, all this network theory is there, so at least there it will helpful. Okay, if you have understood the concept clearly. Okay, and whatever possible from my side I have putting effort here. Okay, so thank you. We'll see in the next video with AC analysis. Okay, AC network node analysis. Okay.